If Earth has a place that works like a secret hard drive storing the planet's most violent chapters, the Mariana Trench is the perfect candidate. Every layer of dense mud, every twisted fracture, every silent landslide unfolding in that immense darkness is more than terrain. It is a living archive, precise down to the last grain, of catastrophic earthquakes, volcanic eruptions, relentless tectonic collisions, and geological changes the world above may not even have noticed yet. At more than 10,935 meters below sea level, the most precise figure recent surveys have produced, the water pressure reaches the equivalent of about 8 tons per square inch, enough to crush almost anything familiar to life on land. And yet, inside that permanent darkness and outward silence, the planet is telling a long, dramatic story about its own formation. We like to think we have mapped Earth. We have climbed Everest, explored ancient shipwrecks, even sent robots to Mars. But Mariana remains a vast blank spot in human understanding, not just because it is deep, but because it is a place where we still infer far more than we truly know. This is not a simple, round hole like the one popular imagination loves to picture. Mariana is an active geological landscape stretching more than 2,550 kilometers in a crescent shape, averaging about 69 kilometers wide, with cliffs rising thousands of meters, vast rough basins, unstable slopes ready to fail at any moment, layered terraces, and countless fractures slicing across it like old scars in Earth's skin. If you took the Alps or the Himalayas, flipped them upside down, and dropped them into the darkness of the ocean, you would have a rough mental picture, an enormous mountain system turned inverted, where sunlight has never reached and never will. That complexity is exactly why we still have not truly seen Mariana. Sunlight penetrates only the upper few hundred meters of the ocean. Down here, every instrument has to battle crushing pressure, near freezing water, and total darkness. Cameras can be crushed, batteries drain fast. Communication signals must travel by slow acoustic transmission, sometimes taking seconds to return to the ship above. So, maps of the Mariana seafloor are nothing like the sharp satellite images we have of land. Most of them are reconstructed from indirect data, scattered surveys, and above all, sound rather than light. Mariana is a place we hear more than we see, a world where sound has become science's only real set of eyes. And the way scientists map this abyss is remarkable, almost like a technological miracle. They use multi-beam sonar, a system that sends out hundreds, sometimes thousands, of sound pulses at once in a broad fan, covering the seafloor beneath and to either side of the vessel. Each pulse echoes back after striking the bottom, and from the return time measured to tiny fractions of a second, along with the strength of the reflection, scientists can calculate depth with astonishing precision and even make educated guesses about what lies below. Hard rock reflects sharply and strongly. Soft mud absorbs sound in a duller way. Every new survey slightly changes our picture of Mariana, as if we are assembling an immense puzzle while only being allowed to see a few pieces at a time. There is something almost poetic about reading a landscape through echoed sound instead of light, like bats navigating a cave, except on a scale millions of times larger. But Mariana is not just a deep trench. It is a record of Earth's own collisions. A natural archive scientists sometimes describe as a living geological file. Here, the ancient Pacific Plate, one of the oldest pieces of oceanic crust on the planet, at roughly 180 million years old, is slowly but relentlessly diving beneath the Mariana Plate, part of the Philippine Sea Plate. This subduction has continued for tens of millions of years, driven by the same types of forces that shaped prehistoric Earth when Pangaea broke apart and dinosaurs lived through the rise and collapse of mountain ranges. The thick sediments and basement structures of Mariana preserve traces of ancient earthquakes, undersea eruptions, and episodes when Earth's crust bent, fractured, and reorganized itself. Scientists can read those layers almost like a stone book. One records a major earthquake thousands of years ago. Another preserves minerals brought up from deep within the mantle. Mariana is one of the longest diaries our planet has ever written, composed not in ink, but in mud and rock. And it is far from geologically quiet. Mariana is a persistently unstable region where tremors beneath the seafloor keep shaking loose steep slopes and triggering colossal landslides. Imagine cliffs several kilometers high suddenly splitting apart, with millions of tons of mud and shattered rock plunging downward like an underwater avalanche, reshaping the landscape in minutes. These earthquakes are not whispers. They are hidden storms, rebuilding Mariana without a single human witnessing the exact moment the transformation happens. In the same way, prehistoric earthquakes buried forests and helped create future coal deposits. Change here is constant and relentless, only hidden beneath a crushing column of seawater. Those landslides, in turn, generate deep-sea cascades too vast for human ears to hear. Mud, sand, and rock fragments surge along the seafloor in dense, fast-moving flows called turbidity currents, sometimes racing at tens of meters per second. These are not gentle currents. They are aggressive underwater rivers of sediment, sweeping away or burying whatever lies in their path, covering old layers, scrambling geological history, and rewriting Mariana's surface by force. Nothing here stays still for long. The trench is continually being edited by its own material, like an oil painting repainting itself every time a hand brushes across it. But Mariana is stranger still. In the forearc region, between the trench itself and the Mariana volcanic island arc, there are mud volcanoes that do not erupt, glowing lava, the way most of us imagine volcanoes should. Instead, they release blue-gray, mineral-rich mud from deep inside the earth. This happens through a process called serpentinization. Water released from the descending slab penetrates mantle peridotite above it, transforming that rock into serpentinite, making it softer and more buoyant, while also releasing hydrogen, methane, and intensely alkaline fluids with pH levels that can reach 12.5. That mud rises through major fractures and builds enormous mud volcanoes, some as much as 50 kilometers across and more than 2 kilometers high. They can carry up strange rock fragments from the deep subduction channel, even high-pressure metamorphic rocks that could only have formed under extreme conditions. Mariana is not only deep, it is geologically bizarre, with chemistry that can evoke the primal environments where life may first have emerged on Earth. A reminder that even in the darkest places, the planet is still running chemical experiments of its own. And inside that dense darkness, Mariana also becomes a surprisingly lively acoustic laboratory. Special hydrophones lowered into Challenger Deep have recorded all kinds of sounds traveling across astonishing distances. T-phase signals from nearby and distant earthquakes rumbling through the water like submerged drums, the low calls of baleen whales, and even the strange sound once labeled biotwang, later identified as coming from Bride's whales. Ships at the surface, air guns used in offshore surveys, and even the roar of a passing Category 4 typhoon can all be detected in the deep. Sound in the ocean travels with remarkable clarity and range, turning Mariana into a place that is both profoundly dark and unexpectedly full of echoes. Down there, you can almost hear Earth speaking through vibrations and reverberations that few other places can preserve so clearly, like a geological symphony that never really stops. What falls into Mariana does not disappear quickly, either. It acts as one of the planet's great traps for material. Large carcasses sinking from above, volcanic ash from distant eruptions, drifting minerals, and fine sediments from across the ocean all accumulate in this deep region. turbidity currents deliver them, bury them, and sometimes preserve them in thick mud, turning the trench floor into the endpoint of thousands of journeys that began in the bright world above. It is a kind of archive where materials from far away contribute to a growing history of the place itself. Much the way dinosaur remains were buried beneath sediment and later became fossils millions of years afterward. For that reason, Mariana is less like a destination and more like an unfinished manuscript. Every pass of sonar redraws a ridge. Every core sample adds a footnote to an ancient catastrophe. Every instrument lowered into the abyss returns with a reminder that the trench is not a static wound in the seafloor, but an active system still being revised by pressure, chemistry, gravity, and time. What looks from above like a single deepest point is, in reality, a labyrinth of basins, slopes, scarps, and channels, each preserving a different part of Earth's long internal conversation. That is why every Mariana expedition is, in some sense, a high-stakes technical gamble. Deep-diving submersibles must be built from specialized materials such as titanium alloys, strong enough to survive pressures that would crush most engineered structures. Batteries, lights, and cameras must keep functioning in near-freezing temperatures and complete darkness. Sampling systems operate with very little margin for error, because a small mechanical failure can compromise the entire mission. Going deeper is not simply traveling farther. It means entering an environment where the laws of physics test the outer limits of human engineering, where even a tiny structural weakness can end everything in an instant. And the more we survey Mariana, the clearer it becomes that this is not a place we have conquered. It is a place we have barely touched with trembling fingers. The more advanced our technology becomes, the more obvious the scale of the unknown appears. Mariana offers one of the deepest reminders of scientific humility. Human maps are still full of blank spaces, and Earth still holds secrets that even our bravest explorers have only just begun to glimpse. And in the end, this abyss is not really the bottom of the world in the way people once imagined. It is a place where the planet stores its longest sounds, motions, and memories, a living recording of the collisions and changes that shaped Earth from prehistory to the present day. Maybe the most fascinating thing about Mariana is not what manages to survive inside it, but what it reveals, that our planet is still unfamiliar, still mysterious, and still inviting us to keep exploring. And who knows, the next descent may write yet another chapter in the longest geological diary humanity has ever been allowed to read.